Hello, welcome back. We are still studying section 1.1. We're on to our third video. We've covered so far identify the domain of a number and evaluate a function from an equation, domain of a function, gain familiarity with piecewise defined functions, and now we're on to introduce and illustrate functions used in economics. So we'll jump ahead again real quick. This is a shorter video, intended to get us familiar with some functions, but more actually getting us familiar with terminology that's used in a typical introductory macroeconomics course. So we have 4 or 5 definitions here basically to throw at you. So demand for a product is unit price, and you can think about this either way. It's definitely the relationship between price per item and how many units are demanded by consumers at that price. So the way it's phrased here, price is the output, and the number of units demanded are the input, and the name of our function is D. Supply is the producer side of that. So supply of a product is the unit price that they're at which they're willing to produce X items. So maybe it makes more sense from the supplier's perspective to think about it from this way. If you know how much you're willing to produce, and then there's a unit price associated with that. There's a pretty distinct law of demand that's seen in economics. It's not as clear that the supply piece of this is quite at the same level of importance as the demand side. But nevertheless, we see a lot of demand and supply curves in introductory econ courses, and we're going to use them in our class too. So revenue is generally associated with product of how many things we sell and how much we charge per item. So if we sell X things and we charge P dollars per item, we're going to make X times P in revenue. So revenue is sometimes referred to as gross profit, so the amount of money that you make before any kind of cost to produce these things are taken into account. Profit is what we get when we actually do consider that cost. So if we take our revenue, we subtract the cost to produce that many items, we get profit. So profit is revenue minus cost. And then finally, we've got average cost. So this is not really a new definition, but it's basically taking the cost function and dividing by the number of things we produce. So if C was our cost function to begin with, and X is the number of items we make, C divided by X would be average cost. And maybe it's worth a note, because we don't see this a lot in math. In chemistry or other subjects, you see it pretty frequently, but we don't see functions with more than one letter represented for their name all that often. So AC is the name of this function. Typically we would just write A or C or something like that, but nothing prohibits us from writing more than one letter to represent the name of this function. So AC is the name of it, and for average cost, of course, and then X is the input. So we'll go through a quick example, and then we'll call this good. So our quick example is, of course, Timmy's water balloons. So Timmy will say, this is the hourly demand. So if he is interested in selling X water balloons, then this is fairly contrived. But let's imagine that this is the how much he's going to make out of this. So this is the unit price per item, how much he can charge per balloon. So 20 minus X squared gives us the unit price per balloon in dollars when X are going to be sold. So we've got the demand piece of it, and the cost says that we'll just throw out a fixed rate here, so it's 50 cents per balloon. So if every balloon Timmy makes is sold, then the profit function looks something like this. So profit, revenue minus cost, so there's just our first definition given what profit looks like. So now we need to break it down a little bit further, because we need to get to the revenue piece of it. So revenue, again, just using its definition, and we're making use of all this stuff we had a minute ago. So X is the number of items that would be sold, D of X is the unit price per item. Those two things multiply together, their product make revenue. This gets a little confusing if we talk about how many products you sell, and then the product of these two numbers. So we'll try to use items or units to refer to how many things we sell, as opposed to product, so we don't get that confused with the math terminology. So following that through, so there's our X still, and then d of x was given up above, 20 minus x squared. So we're just going to borrow that expression, replace d of x with 20 minus x squared. And then finally cost, we've got one more thing going on here. Oh, that's a great color. So cost is a function of x, and we're told that balloons cost 50 cents each. So here's our expression for that. So 50 cents times the number of balloons that we that we produce. So this is a perfectly fine expression all here in the end, but it could get tidier. So if we clean it up and say, okay, here's our profit function all in a tidy little package, we'd have to distribute. So we'd be taking x times 20 and x times x squared. That's 20x. X cubed, so there's our minus x cubed there. And then the last thing that would happen is that we'd have two of these terms that could get combined. So 20x and black is not a good choice. Gray it is. 20x and 0.5x make 19.5x when we subtract them. So at this point, it sort of feels like we've just now gotten to the interesting point of this function. We've established that our profit function can be given as this. This would be the total revenue associated with selling X water balloons. There could be all kinds of great questions we ask about this. What is the profit from producing and selling 20 water balloons? How many would Timmy have to sell in order to make $50 in profit, and so on. But at this point, we were just trying to get familiar with these pieces of terminology and get ourselves a function. That does it for video 3. We'll be back to talk about our last learning objective in video 4 for section 1.1. Thanks.